So hello students, welcome back to the lecture number 17. In this lecture we are going to discuss one more theorem, that is theorem number 8.7. So let us understand the statement of the theorem. So it states that if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Okay. So we have to first understand this statement vividly. So it is given there is a quadrilateral. Let's say it is a quadrilateral. Right? A, B, C, D. Now if in this quadrilateral the diagonals bisect each other, that means it is the first diagonal, it is the second diagonal. So already it is given that ABCD is a quadrilateral, it is not a parallelogram. No, it is a quadrilateral, and in this quadrilateral these two diagonals bisect each other. That means if this is the point of intersection, so this half is equal to this half, this half is equal to this half. Already this statement or this data is given. Now if it happens, then we have to prove that this quadrilateral is nothing but a parallelogram. Okay, in its just previous theorem we have discussed, in a parallelogram the pair of opposite diagonals bisect each other, and now we are going to discuss that if in a quadrilateral the diagonals bisect each other, then this quadrilateral is nothing but a parallelogram. Okay, so let us write what is first given here. Since it is given ABCD is a quadrilateral. ABCD is a quadrilateral. Okay. Then it is given AC and BD are two diagonals, right? Who bisect each other. Suppose this is the point of intersection. And AC, BD bisect each other at O, right? It means AO is equal to CO and BO is equal to D. So you can write implies AO is equal to CO and BO is equal to DO. So this data is given. Now we have to prove ABCD is a what? ABCD is a parallelogram. How can you prove that any figure, any quadrilateral is a parallelogram? If the pair of opposite sides are parallel, okay, then we can say yes, it is a parallelogram. So ultimately we have to prove that in this quadrilateral the pair of opposite sides are parallel and equal. If we can prove this, then we can say yes, it is a parallelogram, right? So let's prove. Okay, so in order to prove it, we have to first consider two triangles, this triangle and this triangle. Which two triangle? Triangle AOD and triangle BOC, right? So let us compare them. Between triangle AOD and triangle BOC. Okay, so let us compare them. First, in triangle AOD, this side AO is equal to the triangle BOC CO, because it is given AO is equal to CO, it is given. Okay, so you can write AO is equal to CO. Next condition, since AC and BD are two lines like this, AC and BD are two lines, then these two opposite angles are known as vertically opposite angle, and we know the pair of vertically opposite angles are equal. So you can write this angle and this angles are equal. AOD is equal to BOC. So AOD angle is equal to BOC angle because they are vertically opposite angles, and the first condition is already given. Now coming to the third condition, in the triangle AOD, this side DO, okay, and in the triangle BOC, this side BO. So DO is equal to BO since it is already given. BO is equal to DO, it is already given. So you can substitute BO is equal to DO since it is given. So this stands for side, this stands for angle, this stands for side. So by side, angle, side congruency, this triangle and this triangle can be congruent. So you can write hence by SAS congruency Congruency. Triangle AOD is congruent to the triangle BOC. Okay. Now we have proved that these two triangles are congruent. Now, if we consider the triangle AOD, right? If we consider the triangle AOD, okay, AOD, then AD is a side of the triangle AOD. Correct? Similarly, if we consider BOC triangle, then BC is a side. This one, BC is a side. Okay, for the triangle BOC. But just now we have proved that these two triangles are what? They are congruent. So what we can write? We can write that their corresponding side must be equal. So we can write AD is equal to BC. It is due to simplicity, or you can write axiom 7.2. So what we have found? We have found this pair of opposite sides are equal. Clear? Next. Similarly, if we consider triangles that AOD, then this is an angle. Yes or no? Yes. So ADO angle is a part of triangle AOD. Similarly, for the triangle BOC, this is an angle OBC. So OBC angle is a part of the triangle BOC. But now we have proved that triangle AOD and triangle BOC are what? They are congruent. They are congruent. That means we can write, if any two triangles are congruent, then their corresponding angle must be equal. So ADO and ADO is equal to OBC. It is due to simplicity. Understood? So we have proved that this angle and this angle are congruent, are equal. Okay. Now, see, if AD and BC are two lines, right? If AD and BC are two lines, and DB is a transversal line. Which line? DB is a transversal line. Then what we have found? We have found this angle and this angle are equal, right? So this angle and this angle are equal. Then tell me, these two angles are known as what? They are alternate interior angles. Okay, but they are alternate interior angles. And what we have found? We have found that their alternate interior angles are equal. They are equal. So we know, according to the theorem 6.5 after 6.6, if there are two lines and a transversal line intersect both the lines, then if any pair of alternate interior angles are equal, then these two lines are parallel to each other. So similarly here, AD and BC are two lines and DB is a transversal line and their alternate interior angles are equal. So we can write AD parallel to BC. So we can write hence AD parallel to BC. Okay. So initially we have proved AD is equal to BC. Initially we have proved AD and BC are equal. That means pair of opposite sides are equal. And now we have proved AD and BC are what? They are parallel. So pair of opposite sides are parallel. So out of the two pair of opposite sides, one pair of opposite sides are parallel and equal. We have proved. So rest of the proof is we have to prove that this side and this side are equal and parallel. So go for them. Okay. So in order to prove AB and DC are parallel and equal, we have to take another two triangles, this triangle and this triangle, right? So triangle. So for triangle AOB and triangle COD, we will compare these two triangles, right? So first, see, for the triangle AOB, this side AO, and for the triangle COD, this side CO, are equal. They are equal. It is already given. Okay, it is already given. Second, if AC and DB are two lines, then these two are opposite angles and they are known as vertical opposite angles, and we know vertical opposite angles are equal. So we can write this angle AOB is equal to this angle, right? COD, as they are vertically opposite angle. Third condition is for the triangle AOB, BO is a side, and for the triangle COD, DO is a side. Okay, and it is given that BO is equal to DO, this half is equal to this half, because two diagonal bisect each other, BO is equal to DO, since it is given. This stands for side, this stands for angle, this stands for side. So by side angle side congruency, we can write this triangle and this triangle are congruent. Okay, so hence by SAS congruency, okay, congruency, the triangle AOB and the triangle COD are congruent. Okay, so triangle AOB is congruent to the triangle COD. Okay, so now we have proved that these two small triangles, this triangle and this triangle, are being congruent. It is done. Next step is, see, if we consider the triangle AOB, then AB is a side of this triangle AOB. So AB is a side of the triangle AOB. Similarly, if you consider COD as a triangle, then DC is a side of triangle COD. But here we have proved that triangle AOB and triangle COD are congruent. Then by axiom 7.2 we can write, if any two triangles are congruent, then their corresponding side must be equal. So AB is equal to DC. So you can write AB is equal to DC. Okay. So what we have found? We have found AB and DC are equal. And AB and DC are what? They are opposite sides. They are equal. Okay. Now it is proved that the opposite sides of this quadrilateral are equal. Initially we have proved that AD is equal to BC. AD is equal to BC. These two opposite sides are equal. We have proved. Okay, now we have put these two pair of opposite sides are equal. Then next step, for the triangle AOB, right? This is an angle. Yes or no? Yes. So OAB is an angle of the triangle AOB. Similarly, for the triangle COD, this is an angle. Yes or no? Yes. So the name of the angle is what? As OCD, right? OCD. But here we have proved that these two triangles are congruent, so that we can write by axiom 7.2 that their corresponding angle must be equal. Okay. So and OAB is equal to OCD. It is due to axiom 7.2. So we have proved that this angle and this angle of the two triangles are being equal, right? Now, if we consider, right, AB as a side, AB as a line, and DC as another line, okay, and AC as a transversal line, AC as a transversal line, okay. Now, what we have found? We have found this angle and this angle are equal. That means this angle and this angle are equal. Just compare this figure with this figure. Okay, so here we have found this angle and this angle are equal. Now tell me, this pair of angles are known as what? They are known as alternate interior angles, right? So OAB and OCB are alternate interior angles, but these are alternate interior angles, and we have found that the pair of alternate interior angles here are equal. They are equal, and according to the theorem 6.4 after 6.5, we know if there are two lines and a transversal line intersect them at two different or at two distinct points, if the pair of alternate interior angles are equal, then these two lines are parallel. So here, since these two angles, or you can say these two angles, okay, are equal, they are alternate interior angles. That is why this line AB and this line DC are parallel. So you can write hence AB is parallel to DC. Okay, AB is parallel to DC. You can write the name of the theorem, theorem 6.4 FA5. Okay. So now we have found that AB side or line is parallel to BC side, and these two sides are pair of opposite sides. Initially we have found AB and DC are equal. Now we have found this line and this line are parallel. Now in this section we have proved AD is equal to BC, this side is equal to this side, and AD parallel to BC. This side and this side are parallel. So what we have found? We have found in this quadrilateral the pair of opposite sides are equal and parallel. Okay. So finally you can write, so in ABCD quadrilateral, the pair of opposite sides are equal and parallel. And we know if any quadrilateral, any pair of opposite sides are equal and parallel, then it is known as a parallelogram. Hence, ABCD quadrilateral is a parallelogram. So finally you can write, hence there is no space, so I am writing here. Hence, ABCD is a parallelogram, and now it is proved. Understood? So what we have done, or what we have concluded here, we have concluded that if in a quadrilateral any two diagonals bisect each other, then definitely this quadrilateral is nothing but a parallelogram. Okay, so this theorem is just opposite, just converse of its previous theorem, that is theorem 8.6, where it is given that in a parallelogram the two diagonals bisect each other. Okay, that is why this theorem 8.7 is also known as converse theorem 8.6, because it is just opposite of the theorem 8.6. Now you understood?